Greetings! Welcome back to my channel. This is a video in my series on the Racket programming language, and this is the second video I'm going to be doing on macros. And I think this will be the first, I think this will be the last in the series on macros for a while before we get into some more advanced topics. It's one of those things where I have found that you need to be fairly experienced with Racket and Scheme before you can understand what's going on. And the reason being is that you are kind of dealing at two levels. You're trying to basically figure out why this code that runs before at compile time spits out the code that should be run at runtime, and how do you debug that, but also make sure that the code you're actually doing does the right thing at runtime. So it is really tricky, and so you have to have a very kind of dedicated understanding of what's going on. But I did go in and basically I adapted this from, again, this great article by Greg Hendershot about the fear of macros. This is the pattern matching part. And so what I did is we have created a record here. And what a record is just kind of something that has, if I define a record here, I'm going to get something that I could create a new record with, and I'm going to have a bunch of accessors. But I can't really mutate a record. I can only create a new record. But when I create a new record, I can use this with form to change what I want to mutate in terms of the field. So going along with this right here, we're going to start out here with the pattern here. We're going to have a syntax case here for the syntax that we're getting in. And we're going to basically, this is a placeholder. This is basically a placeholder for whatever gets passed in at the first part, which is a record. So this gets passed in as the syntax. We have the ID, and then we have a fields, and this field pattern says, okay, we have a list of one or more of these field statements. And so it's gone and said, okay, with syntax. And what this does is this has created a syntax object that I can use called pred ID, which is going to be used for defining the predicate really easily. And then what I've done is it goes off and it creates this huge old list as a syntax object by using a back quote and then some quasi quotes in areas. And if you are familiar with that, I did release a video on how quotes and quasi quotes work, and then how splicing also works alongside those. And what this does is that basically it's fairly straightforward, starting with it just creates a begin block so I can do multiple things. So here, this is what we would call the constructor. So it takes an ID in the fields, and this is very clever use of apply here. And what apply does is basically what it does is it takes this vector thing and goes off and it hands it to ID, makes this list, and so on and so forth. And so this here, looks like real voodoo, but what's going on here is that I'm creating a vector. The first thing in it is it contains the ID as a symbol. The second one is going to contain a list of the field names. And then the second of all is going to just create, well, wait a minute, a list of fields. This fields as a list. And if you look at this, this is really hard to understand. And I was watching, again, a video where they were talking to some of the language creators. It was the Primogen video. They are doing ended up talking to both the people that work, the persons that were working on Odin, and as well as the person that worked on Elixir. And they were talking about why Odin didn't have macros and why Elixir did. And one of the things that was brought up that was a very excellent point is, well, how do you debug macros, or how do you define a compile time? And that's something you should be aware very well of. And what the great thing about it is that Dr. Racket does have something to help without that. It's called the macro stepper. And this was also described in a paper on this. Now, it's like I said, it's not the most amazing experience, whatever. It could, have some, better types of syntax support and all that kind of stuff. But basically, what was interesting about it is that they've gone through and actually did a bit of verification that it does the right thing. And so what goes on here is that it'll go through and you can step through. And so if you go backwards, it's going to say, it's like, and what I've done here is this is a little bit confusing because I've kind of intermingled some of these macros from where I'm using them. In most cases, this would be in a completely separate file, but for the sakes of the video, we're just going to keep them in the one space so we can kind of move back and forth. So I'm going to open up the macro stepper again, and it's going to go off, and if I step forward, it's going to do the macro transformation. And what's done is it basically says, like, okay, this is what I think it's going to turn into. And it's used some interesting types of things here. Note what was got captured as far as what was created in the syntax. So you can see it's got the bindings type of here, all sorts of stuff that's going on. But basically what we've done is it said define name first last, apply vector name first last, list first last. What this does is it basically goes off and makes a vector with basically quote name in it, and this next thing is a list of the fields. So it's quote, this is a list of the fields, and then the values of the fields for the rest of it. And so that goes off and does the right thing. So let's take a look here. And so we have also another macro transformation with the next one's coming up. And so that's going to comes on here. And then we have a defined name. So is this a name record? And basically it's gone off and said, okay, is this what we're going to do here? Test to see if it's a vector, because we're using a vector internally to represent records. So is this R that I passed in a vector? If it is, then check to see if the first value in that vector is a tag that matches what we're expecting, which is that name there. And so we're just kind of using a tag to do the kind of simple type checking. It's not perfect because we could have multiple people define a name record and do something completely different. And how you would handle that would be actually really interesting to see that you wouldn't have collisions between records that had been defined before and where they've been defined in other places. And then we go off and then we just say, okay, we define name first as getting the second value out of the record, and we define name last as getting the third value out of the record. And the way we've done this is by going off and we've basically done this for list form, which goes through and sets F to every value in this fields list. It sets N to in naturals from 2 on to whatever it needs to be. We'll talk about streams later on and how this actually works. And then it goes off and gives us a syntax. We create the accessor ID here, so it is exactly as we expect, name dash first. And then we go off and define it as the following. Accessor ID takes in a V. We just go off and assume we don't do checks here. So this is kind of unsafe, but we just go off and say, okay, grab the grab whatever's in starting at 2 from that vector. And then we've gone off and defined the with syntax, and the with syntax just goes through and copies this through, and we get the next thing going on here. It goes off and says, okay, yep, and so you can kind of see it's gone off and says, okay, let new record, yes, for each record test name. You can see where it's kind of does some substitutions. For example, this field updates is now this list of these things in here. So you can see how this is expanded out. And the thing about it is that what is tricky is that you're in essence having to define whether or not this code works, but also that what is generated correctly. So that's the two levels that you're getting at. And it's hard because sometimes getting to the point where this is even valid syntax is tricky, much less going through and trying to figure out, oh, if I didn't get it right, what part of it in where it was generated in the macro had problems. So this is not a perfect type of thing, but it is a much better type of thing that allows you to see how macros are expanded and how you can go through and at least have some idea of what the code is and where to debug it. So I'm going to go ahead and close this off, and I'm going ahead and run this. And I think there might be some bugs in this, so I'm just going to go ahead and run it. And I am going to go ahead and I'm going to take a look at what test name, which is one of the things that we created, and it does seem to be fine. So if I should be able to do name first test name, and that should return John, and then name last test name, yep, Smith, and then name test name, that's true. And now we can go ahead and take a look at other name. So we can see if other name does what we expect, which is like name first other name. And see what that does. And that returns Jane. So we're good. So, and we can do one last thing is we can just, let's see if this is actually doing what I'm expecting. So let's just go off and run this again. And this time only mutate the last name here. So we'll see what is now the name last of other name. And it is indeed done. Okay. So again, this is a really complicated thing. The reason I bring it up is that In Racket, a lot of the language itself is built not only just on a set of functions like in a library, but also a set of macros which expand the basically the what we would call the special forms that are valid in language. And it turns out Racket is based on a very small core of things that are built in. And if you look at it, what you can do is with a very few primitives, you can actually redefine the entire language in terms of one of the things is that if you wanted to be really strict, and Racket doesn't do this for lots of reasons, part of it's optimization, and then part of it is you just don't have to keep expanding things over and over again in terms of performance for the compiler. But if you just had let and lambda and define those, you can pretty much define all the other things in the language in terms of let rec, all this other stuff, define all these other things in terms of macros themselves. So that's really interesting. Now, the thing about it, which is a little bit frustrating, is when I first started out with this, one of the things that you did is that you didn't have this syntax notion. You didn't have kind of this pattern matching stuff. You actually kind of matched on lists, and there is a kind of a helper function that if you want to kind of do macros the old-fashioned way in Racket, that scheme did them in R5 and R6, then you can do that. The reason they introduced this is that syntax objects, and when you have macros, if you want to use these in a much more robust way, need to have the context of where they appeared in the source file. Otherwise, you're just going to make debugging much more difficult. So it'll be one of those things where it's like, it needs to know what line these things were on, so where it reports this error, and not where it was expanded out. And not only that, the context that's going on, and so on and so forth. So that's why they kind of expanded out these notions into the syntax objects. Now, how to go back and forth between syntax objects is really strange. And this is where it gets kind of, where to use one syntax case, where to use with syntax that defines syntax objects that can be used and stuff like that. Where do you have to escape or for example, in here, why do we have to put this as a syntax object and just reference it here? Why can't we access it outside the pattern? This thing goes into a lot of more information about why we have to do that in terms of where you use syntax where you have to turn it back into syntax context, but I'm still getting deeper into it. It's one of those things where, and again, it's an objection a lot of people have to macros in general, which is like, if you ever wanted to use these, you'd have to be pretty much an expert in programming languages. And I wouldn't necessarily have to be like a PhD level expert, but I would certainly argue that somebody would say it's like, it would be very difficult for someone who wasn't really passionate about this and had to kind of teach themselves to do this without working with somebody that had a really deep understanding of it. And so to expect someone, for example, to write this kind of stuff with an undergraduate level of programming, that's really, really asking a lot. And by default, that means I'm asking a lot of my viewers here to do this, because some of you might not be nearly as interested in languages as other people are and might not have a huge background in them. And so this becomes a very interesting exercise, and why would I ever want to do this? Now, the thing about this is that you would want to use macros as a programmer only as little as humanly possible. This is really a language feature for people that are writing libraries and frameworks. And so there's a level of reuse that you'd want to have there before you went to this level of complexity. And not only that, but there's a level of maturity as a programmer that you would want to do before you use any of this kind of stuff. And it kind of goes into, people's criticism about domain-specific languages. They're really, really good when you have them, but you should only have them when you really, really, really need them. And you shouldn't just do stuff like this unless you really, really want something different. Now, that being said, it does allow things that you can anticipate new uses of the language where you didn't have them before. For example, Racket built up this notion of structs, but not only that, its entire class system is now kind of implemented as a large set of macros in a library, along with some supporting types of stuff. And so you can actually create whole new sets of language features based on this much more smaller set of primitives. And it turns out in the case of programming language semantics, that kind of approach is very, very useful, because you can build up the understanding of these higher level features in terms of how they transform down to these lower level primitives that are well understood in the programming language itself. So versus something like C++, where the notion of a class and all these other things are built in, They're first what they would call first class concepts, or they're concepts that are built into the language and they're not built on more primitives. Then you have to expand the semantic definition of language to really say, oh, this is what classes mean. This is what we mean by we inherit things. And this is what we mean by virtual functions, and so on and so forth. So when Racket tells itself about basically being a language-oriented language, this is what it talks about, is that it has a lot of ways of going in and defining a lot of subsets of its own, of itself, versus just in some cases entirely new types of syntax. For those of you interested, there's a project called Rhombus, which is orienting itself around a completely different set of syntax and fundamental data structure concepts. And it looks nothing like Scheme, but actually runs in this environment very well and kind of utilizes the underlying fundamentals of the Racket environment to create this entirely new programming language in terms of syntax and the supporting libraries for it. And the reason it kind of works is this magic of this special form, this hashtag lang or pound lang form, which tells it, oh, you know, what language this does. And what this really does is this is a signal to the compiler to go off and say, oh, wait a minute, I need you to load up a certain module and set us up certain types of things and set up the compiler so it's ready to do certain types of stuff. So that's what's really kind of interesting about it. And so, again, and not only that, but it also comes with, like I said, the great thing about Dr. Racket is that the macro spec, without this kind of stuff becomes almost impossible, because you can't see exactly what is being transformed and what gets from where. And that is just really obnoxious. And you almost get to the point where you're doing like really crazy printf debugging. So this is a big step forward. And with a few little tweaks, it'd be something that this could be like a pattern for how you'd want to do things in any sort of language that has this kind of stuff. For example, it would be really great if C++ had a notion of something where it says, like, if they had basically a template expander that would show you step by step what would happen when you have a template here and how it gets expanded out into what it actually looks like. You know, that'd be great to have in a debugger. It'd be absolutely fantastic. Unfortunately, the way they do it is not really formulated well enough so they can do this in a formal type of way. The great thing about how they did syntax and macros in Racket is that it's well defined. And so the way that the macro stepper works is literally basically it's generated from the semantics of how that works. And so this is kind of given, this is going to be, this works or it doesn't. So this debugger is in one step literally formally verified to do the right thing. So it's just more about a little bit about the experience and how it works and so on and so forth. And the other thing too about it is that it does have some great stuff here for people that really want to get really, really, really deep into the language. If you see this little thing down here at the very bottom, it has this kind of disabled, it has this kind of standard thing. It's actually fairly smart at going on saying, like, okay there, all right, you want to expand out macros, but you don't want to expand out everything, right? And for most cases, that's exactly right. But one of those things was, actually, no, I really want to do some low-level stuff. I have some low-level macros. I need to really understand what's going on here. So they have a couple things. So it's like hide the Racket syntax, hide library syntax, hide the contracts, hide phases greater than 0. That turns we'll get back to that a little bit later on. We do some advanced stuff, but basically Racket kind of generalized this whole idea of, oh, well, we have a compile phase and the runtime phase, but also allows you to really organize things into multiple compile phases and what happens at each step. And that is partly to support the Racket language itself and how it works. But there's a lot of people that do some complex systems with it, like, for example, typed Racket that uses multiple steps that are multiple phases before they get into the code that is ultimately compiled and run. So let's take a look here. So if I disable this, you'll see that it will go off and say, oh, well, what's happening here? And it will literally take everything out down to the very, very bones of the language. And you can kind of see that the bones of the language is very, very small. It's actually almost remarkably small. It's just remarkable how little of this is really kind of done. It's one of those things where you have, if you look at it, things like you have to define syntax as lambda syntax, let values there. So we got an if, that seems to be built in. We have a let values, that is built in. And then everything else just seems to be built on other types of stuff. So, and if you look at this, this really is, it's a syntax tree. It's really the syntax tree as an X expression. And you can kind of see that as how it's like, you know, gone through and done all this stuff with, I mean, I can't even see what it's transforming here. And the interesting thing about this is that we can go in and maybe see, if we just load up a simple file, like let's say, oh yeah, let's see what this one does. If we go all the way back to my example about looking at basically how to define a stack in a queue, and let's see, let's go to the macro stepper and see what it's done, macro hiding, and we'll step through. And you can start to see we're going boom, 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 you know, all sorts of crazy stuff going on. All the way to here. And so you can kind of see that there's this very core type of thing. There's this core module thing. Also, one of the things that I was really interested in is that there's this notion of, you can basically, I have to remember what this is, but this provides context for where these are evaluated, and this app space is always configured by basically what module you're in. And so, but things like define values is always built in, lambdas is always built in, let values is always built in, but everything else is just built on top of these, you know, other types of things that are going on, which is just really crazy when you think about it. It's really something else. So I won't go in more into this, just that you can kind of see that, oh wow, this is kind of the deepest form of the syntax tree you can get in Racket. And you can see how much of Racket itself really is defined in terms of, wow, there's these macros that get expanded on top of macros. And the reason this works as well as it does is that since macro expansion is fairly well defined in terms of S expressions, and creating X expressions is fairly fast in Racket, doing macro expansions is also fast. And that's what it really comes down to is that mutating, and we're not mutating lists here, but you're even doing immutable stuff. But basically you can do this very, very quickly. It's just transform this into another bigger list through iterative steps very fast. And so the compilation steps for Racket is not terribly quick. It is not as quick as some of the hand-tuned compilers out there that can just inhale code at remarkable speeds. Java is a good example of this. The Seed Shark compiler is something that inhales just remarkable amounts of code in no time flat. It's rather surprising. And so on and so forth. But yeah, you can learn a lot about the language in terms of like, oh wait, you know, you have this let values thing and you have lambdas, what you can do with it. And that's a fun exercise, and we might do that in a later video. Anyway, so we'll talk a little bit later about summing up in terms of metaprogramming and why it's important for you as a programmer to kind of help you get to the next stage of where you want to go in your career. But we'll kind of take it from a more abstract standpoint from now on, instead of what's going on here with macros. And then we'll revisit this stuff and talk about things, how we can even change the language in terms of the fundamental level semantics of it down the road. Anyway, thanks for watching, and please like and subscribe if you've made it this far. I appreciate it, and we'll see you at the next video.